So this video is on estimating a population proportion and eventually finding a confidence interval for the population proportion. And later on we'll determine the sample size necessary for estimating a population proportion with a specified margin of error. There are lots of funny phrases here: point estimate, confidence interval, and margin of error. We will talk about each of these in the sections ahead. So before we start, the population proportion is denoted by the letter P. So if we want to find an estimate for P from the population, so that is the population, and we want to find, or we want to learn, info would be the proper word. So to that end, we would end up collecting a sample from the population, sample of size n. We then make use of this sample to find an estimate. And that we denote by P hat. So point estimate is pretty much a statistic that estimates the value of the parameter. The parameter is something that belongs to the population, so the parameter here would be the population proportion P. And the statistic is the sample proportion. Statistic is any quantity obtained using a sample, and a single value that we obtain as an estimator for the population proportion is what we call a point estimate. So let's say we are interested in the proportion of tuxedo cats in Florida. So if we want to infer about that proportion, we collect a sample of size, let's say n equals 20, and we find out that 10 out of the 20 randomly selected cats are tuxedo. So this would imply the point estimate P hat for the proportion of tuxedo cats in Florida is simply x over n, where x is the number of tuxedo cats and n is the sample size. So in our example, that would be 10 over 20. We end up getting 0.5. So here is another example where we want to calculate a point estimate for the population proportion. In July of 2008, a Quinnipiac University poll asked 1,783 registered voters nationwide whether they favoured or opposed the death penalty for persons convicted of murder, and 1,123 were in favour. So we want to find a point estimate for the proportion of registered voters nationwide who are in favour of the death penalty for persons convicted of murder. So the population proportion here is the proportion of registered voters nationwide who are in favour of the death penalty for persons convicted of murder. So that is P. The sample that we collected is up here, and 1,783 people were asked about it, so that would be N, and 1,123 responded that they are in favour, so that would be X. So P hat, which is the point estimate for P, in other words, it is the point estimate for the proportion of registered voters nationwide who are in favour of the death penalty for persons convicted of murder. And that value is simply X divided by N, so we have 1,783 over, have it backwards, 1,123 divided by 1,783. And that gives us 0.6298. Now, what is a confidence interval? Now, even though a point estimate is great and all, we can't place our faith in on a single value. The reason being sample variability. So if we collect a different sample and found a point estimate, that particular sample will not give us the exact value 0.6298. Rather, it would give you a different value, perhaps 0.64. So from one sample to another, we are going to have variability. So suppose we have sample 1 and sample 2 all the way up to sample 100. So what is a confidence interval? A confidence interval is simply a possible range of values for the population proportion. So obviously, since it is a range, it is an interval, so we would have a lower endpoint or bound, and we have an upper endpoint or bound, and I'll show you how to find the lower and upper bounds. So using this interval, we can conclude that a certain percent of proportions will certainly lie in that particular range. So if we keep on getting different samples, a certain percentage of them would fall in that interval. So that level of confidence is denoted by 1 minus alpha times 100%. Here, alpha is the level of significance, and alpha would always be given in the problem. So if the level of significance is alpha, the level of confidence is 1 minus alpha times 100%. If alpha is not given in the problem, the level of confidence will be given in the problem. So we need one out of the two. So when we say 95% confidence, that would mean alpha is 0.05. The most commonly used values for alpha are 0.1, 0.05 and 0.01. So the corresponding confidence levels are 1 minus alpha times 100%. So we plug in alpha in this particular expression and we get the confidence level. So for the first one we have 90%, for the second one we would have 95%, and for the last one we would have 99%. A key thing to notice here is 95% confidence doesn't imply that I'm certain or I'm confident with a probability 95% that the true value would lie between the lower and the upper bound. Rather, the interpretation is that if we went about collecting sample 1, sample 2, so sample 1, sample 2, all the way up to sample 100. When we find a 95% confidence interval, 95% of these 100 samples, in other words, 95 out of the 100 samples, would produce a confidence interval that corresponds to an interval that we will find. So that's what we mean by 95% level of confidence. That said, we want to know how to find a confidence interval. In general, the confidence interval is the point estimate plus or minus the margin of error. Specifically, when we talk about the population proportion, the point estimate is p hat, and we usually denote the margin of error by e. So, as an interval, we write it as p between p hat minus e and p hat plus e. So we find p hat using the sample, then we find the margin of error, and we plug these two in there to find the interval. So the margin of error is always the product of something called the critical value and the standard error. So the critical value is tied to the confidence level, And the standard error is related to or depends on the point estimate. So when we talk about sample proportions, the the critical value is obtained from a normal distribution I will show you how to find that ahead, and the point estimate is obtained using the sample. The point estimate is p hat, and the standard error is simply square root of p hat times 1 minus p hat divided by n, and n is the sample size. And that is the formula that you see over there. So the next slide simply summarizes what I just mentioned. So for a given value of alpha, we would have a confidence level 1 minus alpha times 100%, and the margin of error is simply the product of the critical value and the standard error. So let me be precise here. Obtained from a normal distribution with mean 0 and standard deviation 1. So what is Z alpha over 2, or that is the critical value, or how do we find that? So we look at a standard normal curve with mean 0, and we allot the amount of confidence between those 2 points. For instance, as an example, let's alpha equals 0.05, which would imply the confidence level is 95%. So we assign 95% right in the middle, which would imply the area there and the area there would equal to 2.5%. So 2.5 is simply alpha over 2. So there is an area of alpha over 2 below that point, and an area of alpha over 2 above that point. So the point here is what we call Z alpha over 2, and the point over there is negative Z alpha over 2. So Z sub alpha over 2 is the positive critical value, and negative Z sub alpha over 2 is the negative critical value. Typically, we don't have to find both the critical values. If we find one of them and we multiply it by -1, for instance, if we find Z sub alpha over 2, if we multiply that by -1, we'd end up getting that. So we want to construct a 90% confidence interval in this example. So this goes back to what we have already, or what we had seen already. The Quinnipiac University poll asked about 1,783 registered voters nationwide whether they favoured or opposed the death penalty for persons convicted of murder, and 1,123 people or voters were in favour. So we have already established that 1,783 is the sample size, 1123 is the value of x. So the point estimate p hat is x over n, which is (1123) divided by 1783. So 1123 divided by 1783, we get 0.6298. So our objective or goal is to find p hat minus e less than p hat plus e. And that is the lower bound of the interval, and that is the upper bound for the interval. So let's construct the interval. The first step is to find the margin of error. So the margin of error is always the product of the critical value and the standard error. So the critical value is z sub alpha over 2, and the standard error, I'll just call it SE. So let's first find the critical value. So alpha in the problem is not given, but it is a 90% confidence interval, which would imply alpha is 0.1. So we have to allocate 90% confidence right in the middle, which would mean half of alpha would be on either side of those two lines, or that line and that line. Those lines correspond to those points, and the area here is alpha over 2, which is 0.05, and the area over there is alpha over 2, which is also 0.05, or 5%. Half of 10% is 5%. So z alpha over 2, 0, negative z alpha over 2. So we know alpha over 2 is 0.05. So let me rewrite that. How do we find those z values? So press second bars. We'll make use of the calculator. Inverse norm, which is number 3. And the syntax is that inverse norm syntax is the area below the critical value, and 0 and 1. So over here, the area above is 0.05, which would imply the area below is 1 minus 0.05. So 1 minus 0.05, comma, 0, comma, 1. Enter. We end up getting 1.645. If we try it on the other side, which is over here, the area is 0.05. So second was option number 3, 0.05, comma, 0, comma, 1. And we end up getting negative 1.645. This is exactly what I meant when I said that if you find one critical value, you could find the other by simply multiplying it with negative 1. So we found the critical value, which is 1.645. The next step is to find the standard error. So the standard error is given by this formula, square root of p hat times 1 minus p hat over n, which is square root of 0.6298 times 1 minus 0.6298 divided by the sample size, which is 1783. So let's go ahead and find that. 0.6298 times 1 minus 0.6298 divided by 1783, and we have to take the square root of the answer. We end up getting 0.0114. So we multiply the two, we would have 1.645 times 0.0114, and we end up getting 0.01875. We'll just round it to 0.0188. So the 95% confidence interval is P between these two values, 0.6298 minus 0.0188, the margin of error we just found, and 0.6298 plus 0.0188. So the population proportion is likely to lie between 0.6110 and 0.6486. So it's going to be somewhere between 61.1% and 64.86%. Even though this process is quite elaborate, the calculator can simply do this for you. All we have to do is press Start, over to Tests, and we scroll down to one prop Z interval, option A. It's asking for the value of X, which is 1123, the value of N, which is 1783, and the confidence level, which is 0.9. Enter and calculate, and we end up getting the same answer, which is 0.61103 and 0.64865. So you can do this manually, or you can simply use the calculator to find the interval. So how would we interpret the interval? that was a glitch, I believe. So the interpretation here is we are 95% confident that the proportion of voters who are in favor of the death penalty for persons convicted of murder is between 0.6110 and 0.6486. So the proper way to interpret this is if we collect 100 samples, 95 out of those 100 will give a interval for the population proportion satisfying that right there. So at times one might conduct a study, have information from that study, and use that information from the study and go for another study. So that's what we mean when we find a confidence interval. When I mentioned the formal interpretation that if we went and collected 100 samples, 95 out of those 100 would give an interval for the population proportion between 0.6110 and 0.6486. So naturally, one might ask the question, well, I did one study, I found a proportion, now I want to do another study, and I want a specific margin of error for the second study. So how many observations should I have in my second study or the third, and so forth? So typically in this formula that you see, p hat is a known estimate, perhaps from a previous study. E is the specified or desired margin of error for a future study, and Z sub alpha over 2 is the critical value, and it is alpha over 2, so the confidence level is 1 minus alpha times 100%, and the significance level is alpha, which is why we have a critical value of Z sub alpha over 2. And our objective here is to estimate the sample size for a future study. Now, if this is the first study that we are trying to conduct and we desire a margin of error, but we don't know p hat. In the previous case right here, we knew p hat from a previous study, and we are doing a future study, and we want to find the sample size of a future study. But what if we do not know a prior estimate of P? In other words, we are planning our first study ever, and we desire a margin of error and that is the critical value, and the study computes a confidence interval with 100 times 1 minus alpha percent confidence, and n would be the estimated sample size. You can notice the difference. Over here it is p hat times 1 minus p hat. Here we have 0.25 because we do not know p hat. How did we get that 0.25? If I make an assumption that p hat is 1/2, then p hat times 1 minus p hat is 1/2 times 1 minus 1/2, which is 1/2 times 1/2, that is 1/4, and that would give us 0.25. Then that's how we got that 0.25 up there. So a sociologist wanted to determine the percentage of residents of America that only speak English at home. What size sample should be obtained if she wishes her estimate to be within 3 percentage points with 90% confidence, assuming she uses the estimate obtained from the 2000 supplementary survey. So, what do we know? We know that she intends to use 90% confidence. She desires a 3% margin of error, and she uses the estimate obtained from the 2000 supplementary survey. So we know a prior estimate for P, which is P hat, that is from Census 2000. We know alpha is 0.1, which would give us 90% confidence. The desired margin of error, E, is 3% or 0.03. So we are planning to estimate N, and that is given by the formula P hat times 1 minus P hat, Z sub alpha over 2 over E, and squared. So we have to find the critical value. The alpha that she intends to use is 0.1, which would imply the area on either side would be half of 0.1, which is 0.05 and 0.05. So our critical values, negative Z alpha over 2 and Z alpha over 2, would become negative Z sub 0.05 and Z sub 0.05, and we can make use of the calculator to find that value. So we make use of the inverse norm function and plug in 0.95. So 90% is in the middle, because our confidence level is 90%, and we add 5% to that, which is right over here, which would give us 95%. So inverse norm 0.95, mean of 0, standard deviation of 1, and we get 1.645. So we plug in 1.645. The desired margin of error is 3%, 0.03. And we plug in the proportions, p hat and 1 minus p hat. So 0.824 times 1 minus 0.824, which is 0.176, times 1.645 over 0.03 squared. And we end up getting 0.436.04, and we round up to get 437 observations. What does this mean? This means our future study or the lady's study should have or must have 437 observations. That doesn't imply that she can have more than 437 observations. So what we're trying to say is we need at least 437 observations. So the same problem, even though this is not in the question, I'm going to do this part. What if p hat from the census 2000 study is unknown? What would she do? Certainly she's not going to abort mission, rather use this formula instead, which is 0.25 times z sub alpha over 2 divided by e squared, which would give us 0.25 times 1.645 divided by 0.03 squared. And 757.67 is what we get, and if we round up, she would need at least 758 observations in the study. Now, as you can see, if we have prior knowledge, it is very likely that we need a smaller sample size because we know something already. So we have prior information and we are trying to get new information about the population proportion. So we need fewer observations, hence if we look up here, we needed only 437 observations, but if we don't have prior information, we need more data, hence there we have 758 observations required for the study. Again, we don't imply that we need exactly 758 or 437. That is the minimum number of observations that we require in order to specify these conditions, 90% confidence and within 3 percentage points or 3% margin of error.